Welcome back to the Deep Dive. Today we're taking a bit of a plunge into the world of enterprise data protection systems. And we're using a really interesting set of sources. They're actually structured around the core concepts you'd find in a high-stakes technical certification exam. We're going to extract the pure operational insights from them.
Exactly. I mean, when you look at the material that system administrators have to know to pass these things, you're not looking at theory. You're looking at the critical, non-negotiable architectural decisions, the ones that govern deployment, management, and, when things go wrong, crisis survival.
So our mission today isn't to quiz you. It's really to distill the what, and more importantly, the why it matters. We're looking for those capabilities that translate directly into things like business continuity, efficient deployments, and of course, cost-effective scaling. And speaking of continuity, let's just establish one baseline concept right up front that we'll keep coming back to. Recovery time objective, or RTO.
Yeah, that's really the most important metric here. Simply put, RTO is just the maximum acceptable amount of time a critical system can be down after something fails. Every single feature we're about to talk about is, in some way, designed to shrink that window, to get you closer to zero downtime.
Okay, that's a great frame. So let's start at the very beginning then, establishing the system. When a company invests in one of these powerful, complex appliances, that initial deployment is, I imagine, the first real point of risk.
Yeah.
If you're doing it all manually, human error has to be a huge factor. So how do these modern systems make sure the setup is fast, consistent, and error-free right out of the box?
Well, they lean very heavily on automation and centralized control, specifically a tool called the Appliance Configuration Manager. You can think of it as like the master architect for the entire system build. It's that single point of entry that standardizes all the foundational parameters.
What kind of foundational parameters are we talking about here? The stuff that, if you get it wrong, could sideline the whole infrastructure.
Precisely. It automatically handles the critical network settings, it sets the time zone consistently across all the internal components, and it establishes the administrative passwords. When you're dealing with a complex system that might have, multiple internal virtual appliances all working together, automating that just drastically reduces the chance of some small misconfiguration. It's all about building the house on a perfectly level foundation.
I see the value there immediately. But it's not just the, let's call it the plumbing and security. That setup process is also where the appliance learns what it's even allowed to do, right? The licensing part.
That's a crucial point the source material really emphasizes. The electronic license file, that's also uploaded through the Appliance Configuration Manager. And centralizing that process ensures that every single component knows the full feature set it's been activated for. If that step were decentralized, you could easily end up with components that don't recognize the licensed capability, and that would create, massive troubleshooting headaches down the line.
Okay, so automated, consistent deployment from the start.
Yeah.
Now let's talk about a requirement that seems almost boring, but the material says it's mandatory: time synchronization. Why is consistent time so critical that the architecture actually demands it? It feels more like an admin chore than a core feature.
Oh, it's the absolute unsung hero of system stability. The mandatory requirement is the Network Time Protocol, or NTP. And the reason it's mandatory really comes down to security and reliability at a micro level.
Okay, give me the why on the reliability piece.
Okay, imagine two components communicating. One logs an event at, say, 10:00:0001, but the other, because of time drift, it records receiving that same message at 09:59.58. Now, when you try to troubleshoot a failure, your logs make no sense. Root cause analysis becomes almost impossible. And even more critically, accurate time is absolutely essential for authentication protocols and for ensuring backup operations happen in a logical sequence. If the clocks are off, security tokens can expire too early, data integrity checks can fail. It's a huge deal.
That makes perfect sense. So the mundane act of clock syncing is actually the prerequisite for sophisticated processes like authentication and reliable logging. If the automated setup is about building the house consistently, then NTP is about making sure every clock in every room is perfectly synchronized. Otherwise, the whole system might just seize up under stress.
That's it, exactly. The consistency enables the speed. We'll see that play out later.
All right, moving on from the initial setup, the administrator's job, it changes fast when they're not just managing one appliance, but maybe dozens across multiple data centers.
Yeah.
You can't live in a world with 20 different user interfaces. How do these systems consolidate all that?
Yeah, that's the definitive need for what we call the single pane of glass experience. And the centralized dashboard that provides this visibility is called Data Protection Central.
So what's a major operational shift it enables? Is it just, pretty graphics on a screen?
It's so much more than visuals. It is pure operational efficiency. Instead of having to constantly switch contexts between different UIs, Data Protection Central or DPC, it aggregates real-time alerts, performance metrics, and system health data across the entire protection environment. So an admin can see in a glance, oh, capacity is running low in Site A or replication failed in Site B, all from one single place. It truly becomes mission control.
Okay, so DBC is tactical. It tells you what's happening right now, who's yelling, and where the
fire is, exactly.
right, where the fire is. But administration isn't just about putting out fires. It's also about long-term strategy, trend analysis, and dealing with, regulatory bodies.
Yeah.
How do you move from real-time monitoring to strategic planning?
And that is where the distinction between DPC and another tool, the Data Protection Advisor, or DPA, comes in. DPA is the tool designed specifically for those long-term insights. If DPC is your operational cockpit, DPA is the strategic planner reviewing the mission after the fact.
I like that analogy. But why do we need two separate systems? Why not just build historical reporting into that central tool?
Well, they serve fundamentally different roles and they use different data sets. DPC is all about immediate health and status, pulling real-time data to help an admin today. DPA, on the other hand, it's designed to consume and analyze massive amounts of historical data over months or even years. Its specialized function is to generate advanced reports for things like capacity planning and, really critically, for specialized compliance reports you need during a regulatory audit.
So DPC is checking that the backups ran successfully last night. And DPA is generating the quarterly report that proves your backup success rate has averaged 99.9% over the last 18 months to satisfy some regulation. The difference between tactical and strategic reporting.
Precisely. It lets organizations evaluate backup effectiveness and capacity trends over long periods, which is just vital for proving governance and for making smart investments in the future.
All right, let's pivot to the moment where time is absolutely critical recovery efficiency. When an admin knows a file was backed up, but they have no idea which backup said or even which appliance has it, finding that one file in a petabyte-scale environment must be like finding a needle in a digital haystack. What component solves that data discovery problem?
That task is handled by a dedicated search engine component. Its whole function is to let administrators find specific files and find them quickly across multiple backup sets and systems.
Okay, but if you're searching across potentially billions of files, you can't be scanning the actual data in real time. How does the search engine get that speed? Is it a big performance hit?
That is the key trade-off. And yes, there's some overhead, but it's worth it. It avoids scanning the data by using metadata attributes, things like file names, sizes, or dates. Or, depending on the policy, it can even do content-based keyword searches. It's essentially a specialized index, kind of like Google, but just for your protected data. And that indexing massively improves operational efficiency. The tiny bit of processing overhead during backup is absolutely justified by the huge reduction in recovery time later.
That's a perfect way to put it. You're indexing your insurance policy. Okay, let's shift gears from daily ops to architectural planning and financial efficiency. For a company that's growing fast, buying a system that needs constant disruptive hardware additions must be a nightmare. What's the solution for that kind of cost-effective, hardware-free growth?
This is where specific architectural models really come into play. The source material highlights one called the DP4400. This system is specifically designed to tackle that exact growth problem.
And what makes it unique in a market that's just full of hardware appliances?
It's designed as an entry-level appliance that can scale its usable capacity exclusively through software-based licensing. So when an organization hits its initial capacity limit, they don't have to go rack and stack new shelves or do a forklift upgrade. They just apply a new license key.
That is a fundamental change in how you budget and plan for capacity. You're shifting a massive upfront capital expense for future hardware to a predictable operational expense model based on actual growth.
Precisely. It allows you to scale over time without being forced to buy substantial additional physical hardware components. It just makes financial planning so much more agile and manageable.
Okay, staying on that theme of cost optimization. Once data gets old, months, years old, it doesn't need to be on that high-performance, expensive storage on the local appliance anymore. You want to move that cold data somewhere cheaper. How does the appliance handle that move to the public cloud for long-term retention?
That capability is managed by the Cloud Tier feature. It basically acts as a gateway and a policy engine. It enables the appliance to seamlessly send data out to supported public or private cloud storage, specifically for that long-term retention purpose.
So it's basically intelligent archiving. It knows the difference between the hot data you need to recover fast locally and the cold data you just have to keep safe for compliance.
Exactly. The key purpose is cost optimization. You offload that older, less frequently accessed data to much lower cost cloud storage solutions like AWS S3 or Azure Blob Storage. It just optimizes the economics of your entire data protection strategy. You keep the expensive local storage for what it's good at, essential high-speed recoveries.
Which brings us to the moment of truth, our final section, crisis management. All the consistency, efficiency, and planning we've discussed, it all leads to this. When failure hits, we are laser-focused on that recovery time objective. How fast can we get back to business? We need features that minimize downtime immediately, especially for virtualized workloads.
And here we have to start with the gold standard, a feature known as instant access. This is really the ideal scenario where a business application, one that's hosted in a virtual machine, needs to be available almost immediately after a failure.
That sounds like magic. Traditional recovery means you're waiting hours for terabytes of data to copy back to production storage. How does instant access just bypass that long wait?
It changes the mechanism completely. Instead of waiting for a full restore, instant access lets the virtual machine run directly from the protection storage itself. The appliance presents the backup copy to the hypervisor as if it were local production storage.
So the system is running the critical workload right now, and the full data transfer, the cleanup, that's all just happening invisibly in the background.
That's exactly right. Immediate access is enabled while the full data transfer happens transparently in the background, using resources without impacting that immediate recovery. This mechanism is the single most effective way to drastically reduce RTOs for virtual environments.
Instant access is fantastic for localized failures, data corruption, that sort of thing.
Yeah.
But let's talk about the ultimate nightmare, a catastrophic disaster. The entire on-prem infrastructure is gone. Your data center, your appliances, your servers, they're inaccessible. Where do you recover that?
At that point, you need a robust, geographically distinct safety net. And that is what the Cloud Disaster Recovery feature provides. It ensures business continuity by letting you restore virtual machines directly into supported public cloud environments.
And based on the operational needs, that means leveraging the massive global infrastructure of the big hyperscalers.
Precisely. The supported targets for this are Amazon Web Services, AWS, and Microsoft Azure. This capability is absolutely vital because it ensures that even if you lose your entire physical location, you can bring up and run your business infrastructure completely off-site with zero dependency on that compromised data center.
That is the ultimate expression of minimizing your RTO in the worst possible scenario. We hope this deep dive gives you not just a list of features, but a real operational understanding of why these components matter so much when your data and your business are on the line.
We'll see you next time.